Yeah, hi, John Kennedy here. I'm an acupuncturist from Masterton, New Zealand. I've done 4 years full-time study at the New Zealand School of Acupuncture and Traditional Chinese Medicine. I'm the owner of the acupuncture clinic in Masterton. I've got 23 years of clinical experience, including all aspects of traditional Chinese medicine, diet and lifestyle. In 2007, I developed a very strong passion for understanding adult stem cells and their role of healing within the body. I'm here today to talk about how the carnivore and keto diets have a role in adult stem cell physiology itself. We get asked a lot of times, are the keto and carnivore diets actually healing? We see a lot of anecdotal evidence that, people who choose these ways of eating, they do get improvements in their health, both through physiological changes, changes in their blood levels, so overall getting better and healthier. So is it these diets, or what is it about these diets that actually has people getting better? Now, these diets are not healing in of themselves. It's more about the elimination of the sugar, the carbohydrates, the processed food, and the vegetable oils and processed seed oils. It's because these things here create a lot of inflammation. And as we reduce the inflammation in our bodies start to work better. The inflammation is implicated in so many different disease processes within the body. I'm here to tell you a different way of looking at what inflammation actually does. And so why is inflammation so important? It's because it has a negative effect on adult stem cell physiology. So first of all, what are adult stem cells? Adult stem cells are found in the bone marrow, and they are capable of duplicating themselves and repopulating themselves. They also can differentiate into other types of cells within the body. And why is this so important? It's because they're at the core of our body's renewal system. So we all know that we're losing millions of cells every day. For example, our eye cells only live for 2 to 3 days and then they die. Gut cells live for 3 to 5 days and then they die. Our liver cells live for about 6 to 7 weeks and then they die. Kidney cells 8 to 12 weeks. Lung cells have a lifespan of 10 to 12 weeks, and our heart cells live for about 4 months before they die. So we're always in this constant state of renewal within the body. For example, we have a new intestinal lining every 5 days. We have a new liver and a new pancreas every 3 to 5 years, and we have a new lungs and new heart every 4 to 5 years. So the question is, how do these stem cells actually repair? Now, as the cells in our body reach the end of their lifespan, they then send out a signal to the bone marrow. The bone marrow then releases stem cells into circulation, and when those stem cells find where those damaged cells are, they migrate through the capillary, they come in contact with that dying cell, and they switch on the gene and become a brand new healthy cell of that type. Then that old cell migrates out into the circulation, it's taken through the body and disposed of or catabolized. So that's how our daily cycle of repair works. And just as our cells age, we also have injuries. So if we were to injure ourselves, like we hit our thumb with a hammer, we fall over, we fall off our bike, those damaged cells send a signal to the bone marrow. The bone marrow releases those stem cells into circulation, and then those stem cells turn into the tissue that we need to repair. So they'll turn into new skin, new ligament, tendons, new blood vessels or nerve cells. Again, whatever our body needs to do to repair that injury. Now, another type of injury is an intentional injury. This is where we go to the gym and we damage our muscles through putting them under a lot of strain. So again, those damaged muscle cells send a signal to the bone marrow. Bone marrow releases those stem cells into circulation, and they turn into new muscle cells. This is how we build muscle. Proteins and amino acids, they're providing, very essential building blocks, but it's the stem cell physiology that is actually causing our body to repair and our muscles to get bigger. And at a deeper level within the body, we have our glands, and our glands produce the hormones in our body, which creates a healthy environment in which our cells live. And if we've got glands, as their cells die off, they send out the signal to the bone marrow does the stem cell thing, and then those stem cells go and turn into new hormone producing cells. So if we think about that, we can look at if our glands that produce the hormones, if they have cells that die off that don't get replaced, then those glands can't produce the right levels of hormones, and we get hormonal imbalances within the body. And those can lead on to any number of types of illnesses and diseases. So what happens here is that inflammation blocks that signaling between the damaged cells and the bone marrow, and it also blocks the signaling between the stem cells and the damaged tissue, knowing for those stem cells to know where to go and do that repair work. So as we improve our diet and we reduce our inflammation, our stem cell physiology gets back to normal and our body starts repairing. So this is why we see a reduction in those inflammatory causing foods. A reduction of those does equate to our stem cell physiology working better, and our stem cells can then go and repair those organs and tissues, and we can gain and regain lost health. One of the problems is, though, our adult stem cells can get stuck. As we age, our circulating stem cells decrease. At 20 years old, we're said to have a 100% stem cell release. By the time we reach 50, our stem cell release rate is down by 50%. And just 15 short years later, our stem cell release rate is down to only 10% of what it was when we were 20. So our body's ability to repair and regenerate itself is significantly reduced. Other things like lifestyle, stress, emotional or physical, poor sleep, toxins, diet, too much or even too little exercise, and illnesses can also reduce our bone marrow's ability to release those stem cells into circulation. And when we have lower numbers of circulating stem cells, that can result in, if we have an injury or an ongoing problem, it takes lots longer to actually recover from that. So lower and slower recovery rates. Less circulating stem cells can also result in the development of illness. As I was talking before about the glands of the body, the substantia nigra, responsible for the production of dopamine with Parkinson's, that gland can deteriorate by 70% before you show your first symptoms of Parkinson's. And again, diabetes, where the pancreas has lost enough cells that it can't produce enough insulin for people. Macular degeneration, where eye cells are dying off faster than they can be replaced. And this goes on for many, many different illnesses and conditions within the body. So recent adult stem cell research, there's hundreds and hundreds, if not thousands of published papers now that show things like, bone marrow stem cells can form liver, skin and digestive tract cells. Adult stem cells from the bone marrow have demonstrated the ability to induce renewal of the pancreas. Mobilized stem cells from the bone marrow can show the renewal of cardiac tissue. Bone marrow stem cells have shown the ability to participate in the renewal of retinal tissue in the eyes. Dr. David A. Prentice, a quote from him, adult stem cells have significant capabilities for growth, repair and regeneration of damaged cells and tissues in the body, akin to a built-in repair kit or maintenance crew that only needs activation and stimulation to accomplish the repair of damage. Direct stimulation of endogenous, that is already present in the body, adult stem cells within a tissue may be the easiest, safest and most efficient way to stimulate tissue regeneration, and such stimulation need not rely on any added stem cells. So the question is, does improved stem cell physiology make a difference in real life? Well, in longevity terms, we can look at the Japanese. So why do the Japanese people live so long? A lot of them say, they got the mountain air, they eat lots of seafood, etc. But it's really been quite a mystery. But what we do know is that Japanese consume more wakame, more seaweed than any other population. So wakame, also known as Undaria pinnifoetida, has actually been clinically shown to increase the numbers of circulating stem cells in the bloodstream. So technically the Japanese people are eating stem cell nutrition, so their bodies are repairing and regenerating at a higher level by taking this food in on a daily basis or a bi-weekly basis. So they're actually doing the stem cell nutrition. So how can we live longer and healthier? Of course, we can eat single ingredient foods, whole foods within the body, not increasing our inflammation. We can do exercise, and we can somehow improve our stem cell physiology within the body. These are the three key areas of ongoing health. So stem cell support. We know that the Japanese are eating wakame, and it does have a positive effect on their stem cells, and we know that increasing your stem cells or having your stem cells working better allows your body to repair at a greater rate. Other plants that have been researched and found that help with stem cell physiology are AFA, or Aphanizomenon floss aqua, and also spirulina. Spirulina contains a very specific compound that helps with the signaling between the damaged cells and the bone marrow. So those are there. Now I have been using in my clinic since 2007 a clinically proven stem cell nutritional product, Stem Enhance Ultra. And this product has a double-blind, placebo-controlled crossover study that's been published in the Journal of Cardiovascular Revascularization Medicine, and it shows that within 60 minutes of consuming 2 capsules, you actually have a 25% increase in the numbers of circulating stem cells in your bloodstream. So what does this actually mean in real life? Well, here's a very interesting study that was done. There were some mice that were irradiated to kill off all of their adult stem cells, and then one stem cell was reintroduced, but this stem cell had a fluorescent tag from a fluorescent jellyfish, so that when all of the daughter cells from that stem cell would be fluorescent, because otherwise stem cell physiology is an invisible process. So by adding in this fluorescent protein, we're able to actually follow and see where that stem cell goes to, what it has done. And not only did it repopulate the entire bone marrow population, but these stem cells actually went out and turned into every type of tissue in the body. But for example here, we have the normal daily repair of a muscle. This is the anterior tibialis muscle in the leg of a mouse. Now this mouse is just walking around it's got cells that die off, and as those cells die off, they attract those stem cells, and those stem cells are fluorescent. Now, here is a normal repair of an injury. So this mouse is walking around, it gets an induced muscle injury, and because now we've got actual injury to the body, those stem cells are then being attracted to there by the damaged tissue, and we get that repair. Now, if we actually start to increase through stem cell nutrition our own stem cells, when we actually injure those muscles and we use stem cell nutrition to increase those circulating stem cells, you can see here that we have a much greater repair of the body, much greater repair of that tissue. Now, when those mice were sacrificed to have a look, there was increased circulating stem cells and stem cell repair in the eyes, the liver, the kidney, the spine, the muscles, all of the other different tissues in the body. So it wasn't isolated just to the muscles themselves. Now here's an example with some vision. Improvement of macular degeneration. 2 capsules twice a day for 4 months, and their vision improves. We've seen 81-year-old gentlemen growing knee cartilage and improving bone density using 2 capsules twice a day for over 7 months. He was on the waiting list for a new knee replacement, and as we can see here, he's got no cartilage in his knee, and just 7 months later his cartilage had grown back and his bone density had actually improved as well. So everybody can improve and become improved from where they are by improving their diet and supporting their stem cell physiology. So whether people want to regain lost health, or if they want to maintain existing health, or push their body to a whole new level of health, then as you can see, everybody can change their diet, improve with stem cell nutrition, improving their stem cell physiology and their body, and helping their bodies just repair at that greater rate. So a disclaimer here is that Stem Enhance Ultra does not treat, cure or diagnose any medical condition. The only thing that Stem Enhance Ultra does is to increase your body's own circulating stem cells. It's those stem cells that then go out and do what they need to do. So we're just supporting your body's own natural repair system. So if you'd like to contact me for more information on Stem Enhance Ultra, or have any questions regarding this presentation, or you'd like to talk to me directly, you can visit me at johnstemcell.com or email me at johnsarul@gmail.com. Thank you very much.